All right, and welcome back. This is the question you were supposed to do on your Canvas. Let's go ahead and do it together here. So we have angle, angle, side. We have two angles and a side. So this one's going to work out without many problems. So we are going to draw a picture, and we've got a 100-degree angle. So that's kind of like that-ish. Right, we got kind of close here. So that's 100. That's C. B and A here. Our B angle is this one at 34, and the B side is 8 over there. Okay, so we are missing angle A, we're missing side A, and side C. All right. So we have two angles inside the triangle. That makes it easy. Angle A is just 180 minus 100 minus 34. And so that's going to subtract down to, let's see here, 180 minus 100 is 80, minus 34 looks like 46. Okay. And now let's go ahead and find side A, which we're going to do with law of sines. So I have sine of 46, that's my angle A, over A. And B is the one that I have both angle and side, so that's going to be sine of 34 over 8. And so A then times sine 34 equals sine 46 times 8. Which means A equals sine of 46 times 8 all over sine of 34. And when you do that up in your calculator, you end up with 10.29-ish. Right? We might have some rounding differences if you're doing it, but you should get right around 10.29. So side C now, we can do the opposite here. So this law of sines will be sine 100 over C equals sine 34 over 8. And cross multiplying, we get sine 34 times C equals sine 100 times 8. So therefore C equals sine 100 times 8 over sine of 34. And when we do that up in our calculator, we end up with 14.09. And there we go. So if you had a hard time with this one, right, make sure you raise your hand and ask a question. Don't just sit there. Otherwise, let's go ahead and move on to the side angle case. Now, this one presents a problem because two angles in one side will always determine exactly one triangle. But two sides in an angle can determine one triangle, two triangles, or no triangles. We have situations where, depending on the given sides or the given angles, we have different possibilities for what can come up as the triangle. So we need to look at the size of the angles and the sides to determine how many possible solutions. So with these problems, we were straight, go ahead, draw the picture, do law of sines. But for these ones, we need to look at how many solutions there are first. So we've got a little graphic here to kind of help us out. If we have a triangle where we're given sides A and B and angle A, by fixing side B and angle A, we can sketch the possible positions of side A to figure out how many triangles can be formed. Depending on the size of the angle and the size of the sides will determine that. Now, this H right here is this. H equals B times sine A. So if A is an acute angle, we'll need to calculate the height to figure that out. However, if A is obtuse, notice that an obtuse angle larger than 90, if A is smaller than B, then there's no way to make a triangle. If B is bigger than A, then A is going to swing down here and it won't reach the side. And if it's exactly, then it's going to be here and it won't make a triangle. So in order to make a triangle, A has to be bigger than B. So you're going to check at the beginning here, if angle A is obtuse, then you're going to see if A is less than B. Because if it is, there's no solution. We can't do it. However, if A is obtuse and A is larger than B, then it will form a triangle. And in fact, it'll just be a single triangle that can be formed. If A is acute, however, that's different. We're going to have a lot of different situations if it's acute. So if we calculate the height, and you should see in this picture, think of this line right there as being the height. And so you can see that if the height is larger than A, then A will not be able to reach the line down here. So if this line is longer than this line, we cannot make a triangle. So that would be no solutions. Nope, not slotions. No solutions. That looks awful. Sorry. If H and A are the same, right, that would be this line right here, then that means a single right triangle has been formed. So there is one solution. If A is larger than B, if A here is larger than B here, then again, we end up with one triangle, which creates one solution. We're freaking out again. And finally, the really weird case is if H is smaller than A, but A is smaller than B, then notice we can have two triangles that get big, that can happen, right? So if the height, this little line right here, is smaller than A, then that means A can make two different triangles. It can make a triangle here, and it could make a triangle there. One where A is an obtuse angle, or sorry, not A, where B is an obtuse angle, and one where B is an acute angle. In this case, we can have two solutions. This, by the way, is why SSA has such a problem, is because we don't know, without knowing all of the sides, which case it's going to be. And even if we know the sides, well, it might have one where there's two possible ways to make the triangle. So let's go ahead and do some examples of this. And we're going to do one with one example first. Notice here, the first thing we're going to look at is the angle acute or obtuse? And remember, acute means that it is smaller than 90, and obtuse means that it is larger than 90. So in this case, we have an obtuse angle. And so we're going to look at this little line right here. So we're looking for, is A smaller than B or is A bigger than B? And if you look here, A is 20, B is 11. So A is larger than B, which means we have one triangle. So since we have one triangle, we're just going to do it like we did the last problem. Okay, we're going to draw a picture. This is a triangle that definitely works, and it's going to be done exactly how we did the last one. So that's 115, and so that's my A right there. So that means this side is 20. That one will be B, and that one will be C. And so this side over here is 11. So there's a nice picture of what we're doing. Now notice on this one we can't find angle C. We can't do one of the angles right away because we only have one. So we're going to have to find an angle first. And as it turns out, I can't do angle C, because to find angle C, I need side C. And to find side C, I need angle C. So that doesn't work. But since I have side B, I can find angle A, or sorry, angle B. So this will be sine B over 11, right? Because I'm looking for B, and I have the side. And then I have both for A. So this is sine 115 over 20. So cross multiplying then, I end up with sine b times 20 equals sine of 115 times 11. So sine b equals sine of 115 times 11 divided by 20. And when you do that up in your calculator, you end up with sine b equal to approximately 0.498. Now I'm rounding off there, so our answer is going to be a little bit inaccurate. And then we're looking for an angle now, which is different than our last problem. When we're looking for angles, remember, we do the inverse sine. So on your calculator, you're doing that inverse sine button. But when you do that, you get b equal to 29.87. So angle B, which we're looking for, is 29.87. Still looking for angle C and side C. Well, the good news is that if this is 29.87, then I can now find angle C, because interior angles of a triangle are going to add to be 180. So angle C is 180 minus 115 minus 29.87. And that comes out to be 35.13. So now we have that side, or that angle. And now we just have to find the last side, which is opposite the C. So when I set up my law of sines, I've got to use the angle for C, 35.13 over C. And now I can choose, since I know angle B and side B, I could use that for my other one, but I'm just going to use angle A again. So this is sine of 115 over 20. And we'll cross multiply and solve just like we did before. So this is C times sine 115 equals sine of 35.13 times 20. So therefore C equals sine of 35.13 times 20 all over sine of 115. And we do that up in our calculators, and we end up finding that to be, let's see here, sine 35.13 times 20 divided by sine of 115, 12.7. Rounding, 12.7. And that's it. So we've solved the triangle. I have all the angles. I have all the sides. The differences being when we're finding an angle, make sure we do inverse sine. But ultimately, we're just doing the law of sines twice to find the two missing pieces. All right, I've got a practice problem with that will have one solution for you in the next video, or in your back in your Canvas. So please go do that, submit your answers, and then we'll see you in the next video. Thanks.